As a global organization with a long history, we've established Bruker as a trusted partner in the field of imaging and analytical solutions. Our commitment to excellence and innovation has earned the trust of our clients and partners worldwide. We take pride in our ability to deliver high-quality products and services that meet the evolving needs of the scientific and medical communities. Our reputation as leading provider of imaging solutions is built on years of experience and a deep understanding of our customers' requirements. Our expertise in X-ray imaging has positioned us at the forefront of the industry. We have consistently pushed the boundaries of what is possible, developing cutting-edge solutions that set new standards for performance and reliability. Our expertise is unmatched, and we continue to invest heavily in research and development to ensure that our products remain at the leading edge of technology. This dedication to innovation is reflected in our comprehensive portfolio of imaging solutions. Our range of instruments is designed to meet the diverse needs of our customers. From floor-standing multi-scale nano-CT instruments to benchtop micro-CT systems, we offer solutions that cater to a wide variety of applications. Our products are designed to deliver exceptional performance and reliability, making them indispensable tools for researchers in materials and biomedical research. The versatility of our portfolio ensures that we can provide the right solution for any imaging requirement. The non-destructive 3D imaging space is ripe for innovation, and we are excited to introduce our fourth-generation benchtop X-ray microscope. This new system represents a significant advancement in benchtop imaging technology, offering unparalleled performance and flexibility. I am proud to introduce the X4 POSEIDON, the first true multi-scale benchtop X-ray 3D microscope, designed to meet the needs of a wide range of users, from quality control to cutting-edge research.
For centuries, optical microscopy has given us a detailed view of the world. Bound to the surface, incapable of revealing what lies beneath. What if we could see inside? What secrets can we unlock? The time is now. Introducing the X4 POSEIDON, the essential 3D microscope. The power to see inside with a refined view. See objects in their totality, or focus on the most important detail. Unlock the power to not only see what lies beneath, but to imagine a whole new world of possibilities.
The X4 POSEIDON is a groundbreaking modular benchtop platform designed to revolutionize your workflow. This innovative system is fully configurable and allows multiple options for several components. This way, you can customize it to your specific needs. You can configure it as a workhorse solution with a reflection source and flat panel detector for screening studies, for example, but also as a high-end research solution with a 2-micron spot size transmission source and 2 different detectors. The modularity not only enhances flexibility, but also ensures that the platform can support future innovations, making it a long-term investment for your laboratory. Performance is at the heart of the X4 POSEIDON. It delivers excellent speed, a proven 2-micron resolution, and an impressive field of view. This ensures that you get the most accurate and detailed results. The advanced scanning modes further enhance your capabilities, allowing you to tackle a wide range of applications with ease. We are confident that this product will set new standards in performance and efficiency. Accessibility is another key feature of the X4 Poseidon. By listening to feedback from our users, we incorporated your suggestions to create a system that truly meets your needs. The hardware and software have a user-centered design. It makes it easy for novice users to get started and offers powerful features for experts. The software also supports multiple languages, ensuring that users from different linguistic backgrounds can fully utilize its capabilities. We also integrated a user and data management system that allows efficient handling of user information and data security. We hope that you will be as excited about these new features as we are, and are looking forward to seeing the fantastic work you will accomplish with the X4 Poseidon.
Well, hello, everyone, and welcome to our event. We are very, very excited to introduce our new system, our new X-ray microscope, the X4 Poseidon. So I'm joined here by Diederik and remotely by Kjell. Welcome.
Hello, everyone.
All right, just a few logistics here for everybody joining us on the platform. On the side of your screen, you'll see a few tabs. One says event, that's a chat. But then the stage tab, you can actually type in your questions that you have, submit those, and then we'll answer them here live. Now, on the other side of your screen, you'll see several buttons. One of them says sessions, one says expo. After the main event presentation today, you can click session, and we're going to do a live demonstration of the X4 Poseidon. In the expo area, you'll find additional information and a contact in case you want to reach out to us for more info. So to kind of kick things off, yeah, what do you think is the most exciting thing about the new X4 Poseidon?
Well, I think, John, the most exciting thing is the fact that you can really configure the system depending on your needs, whether you have high throughput screening applications or high resolution research questions. Everything can be answered with the X4 Poseidon, and together with sales, you can really configure the system to meet your needs.
All right. And Diederik, this platform concept kind of that Kjell was alluding to, how do you think that's going to transform the space of these 3D X-ray microscopes?
Well, the nice thing is that with the X4 Poseidon, we have now really designed the system from the ground up to be configurable and to be really a platform system. And what we try to achieve is to make a modular system now, but also make that system future-proof so that when new technology emerges, we can actually add that to the system much more easily than we could before.
All right. And what do you guys think? Is there like a technological breakthrough here that had to occur in order to enable this platform design in the benchtop?
Well, what do you think? It's basically clever design, right?
I think it's a very clever design. Yeah, of course.
So, I mean, I know a lot of the technology has kind of done this trickle down, though. So we have the 2214, that's our nanotomography solution, which had the multiple detectors. It had the ability to change the distance to really optimize that speed parameter. So kind of that trickle down genetics, almost, I would say, was really key to bringing it to the platform itself. Now, we did hear, though, that kind of the source technology that we've done some advancement there, too, right? Integration of newer things. And also on the detector side, maybe one of you could elaborate a little bit about that.
Yeah, gladly, John. So that's a good point that you now bring. The X4 Poseidon has a lot of the benefits and a lot of the design characteristics of the 2214 indeed. So it is a system that is configurable on the source side. So we have at this moment in time 2 source options. So a workhorse solution, 100 kilovolts, high power, 20 watts, and a research solution with a resolution up to more than a factor of 10 better than previous systems that we delivered. And on the detector side, we have now the option to choose either a flat panel system, a modern small pixel size flat panel with optimized phosphor, or a scientific CMOS sensor, or both even if you want to enable multivision. Yep.
All right. And maybe, Kjell, could you tell us a little bit about the X-ray side of things? To people who are new to 3D microscopy or micro-CT, it might be a little intimidating, the thought that we're going to have, an X-ray machine. It produces radiation in a lab environment. Is this thing fully safe? Do they have to have concerns about that?
Of course, everything is perfectly safe. So to shield the X-rays, there's quite a bit of lead. That also explains the weight of the system. Altogether, it's about 350 kilograms. But that makes no X-rays reach the outside. So the operator is perfectly safe.
So, in that regards, I mean, do you have to have previous experience with X-ray machines, or is this something that really, I mean, you just take it out, put it on a bench, you get a little bit of training, and we're good to go?
Yes, exactly. It's rather plug and play. It's very intuitive, especially with the new software. Even for novice users, predefined protocols can be loaded. You can turn the software into a fully advanced mode where you see all the options, or you can also put it in an easy mode, which will limit the number of options you see. So depending on your level of expertise, and training does come with the system, of course. So we don't leave it to you without any training. You will be up and running in just a few days.
All right. Now, in terms of advanced microscopy, so we think about every lab has a benchtop optical microscope, just about. It's one of those ubiquitous technologies. Everybody needs it. Everybody has it. Um, then what we saw, starting about 20 years ago or so, was really the SEM took over as that new technology to really be a high-end lab. You should have an SEM. Micro CT, on the other hand, we've seen this kind of rising potential for it, especially across the spectrum, life science, material science. Now, how do we kind of think about it in relation to SEM?
So I would say it's a complementary technique in many aspects, right? So an SCM is the ultimate tool for high resolution imaging. However, it is bound to the service, right? It's a service analysis tool. Admittedly, a FIBSEM you can basically etch layers of your sample, and by doing so, you can create a 3D image. However, it is a destructive technique, and it is it allows you to analyze reasonably small areas. This is complementary in the sense that it is non-destructive, and it allows you to analyze real large volumes in a non-destructive way and with high resolution.
All right. Now, when I hear though the term CT, the other thing that kind of comes to mind for me is these, very expensive medical machines.
Oh yeah,
And we're talking like
yeah.
millions and millions of dollars. So, we're sitting here trying to say this should become an indispensable tool in every lab. And yet, $1 million price tag, that sounds like it's only for specialist labs. How does the X4 kind of fit into that position?
Kill, I love this question. So, what we try to do, and you will see it in all our communication. So, the objective here was really to create a microscope that could be used in almost any lab, and that is accessible, and not only accessible as in easy to use and with a easy to use workflow, multi-language support, but also accessible financially, right? So this system is priced at between a high-end optical microscope and an entry-level floor standing SEM system. So in that sense, no, $1 million is way too much money. You can buy several of them for that money.
Yeah. And, feel free to reach out to any of our sales representatives. Like I said, you can go ahead and contact them at the expo, or, search our website, browse the website, and then reach out to us. And we can get you a quote for the instrument right away. So make sure to do that. Now, we did have a question pop in here, and that is from David Downing. And the question is, how does the higher resolution affect scan times?
Gil, this is for you.
That's indeed a very interesting question, and indeed, scan time very much depends on resolution. To reach the highest resolution in the system, we have a 2-micron focal spot size source, a transmission type source, and that 2-micron spot size is achieved by turning down the power to 2 watts. That, of course, has an impact on the exposure times. So high resolution scans take longer than low resolution scans. To answer how long exactly, well, that depends on a lot of parameters, including the sample density, the sample size. But I would say if you want to scan in the range of microns, that will be a scan starting from, let's say, half an hour up to several hours to really beat the most out of the system.
All right, great. So what we're going to do is we're going to move on to the next part of our presentation here, and we're going to hear about both the R&D and also some of the application work done with the X4 Poseidon.
Our team of engineers has worked tirelessly to push the limits of what can be accomplished in a benchtop system. By incorporating the latest advancements in technology, we have created a product that not only meets but exceeds the expectations of our users. The integration of Gem Plus technology ensures that the X4 POSEIDON delivers unseen performance and reliability, making it a superb addition to any laboratory or research facility. One of the key features of the X4 POSEIDON is the high-precision rotary stage. It lies at the heart of the platform, making it crucial for achieving the level of accuracy and precision required. Our engineers have designed the rotation stage to be both robust and precise, available both with or without micro-positioning. The X4 POSEIDON is built on a future-proof platform, which means it's designed to accommodate new technologies as they are emerging. This ensures that our users can continue to benefit from the latest advancements without needing to invest in an entirely new instrument. The hardware of our product is designed to be both powerful and versatile, with one system offering many configurations to suit different needs. This adaptability is a key factor in making our product a long-term investment for our users. In addition to its impressive hardware, our X4 POSEIDON also features a completely new software package that integrates the full user workflow. This means that users can manage the entire process from start to finish within a single platform to streamline operation and improve efficiency. The software is also allowing users to add new features and capabilities as their needs evolve. Overall, the development of the X4 POSEIDON has been a journey of innovation and dedication. From the initial concept to the final design, every aspect of the product has been carefully considered to ensure it meets the highest standards of quality and performance. We are providing our users with a powerful tool that can help them achieve their goals and drive progress in their respective fields of business and research.
The user experience of our X4 POSEIDON is truly transformative. The system has been designed to cater to a wide range of application markets, including the pharmaceutical industry, energy storage, geology, mineralized and soft tissue research, plant and animal biology, and paleontology. Users from these diverse fields can now access advanced imaging capabilities that were previously out of reach, enabling them to conduct more detailed and accurate research. With the X4 POSEIDON, we hope to make CT as commonplace as optical and electrical microscopes. One of the many standout features of this product is the adaptability of the hardware. The system is customizable to meet specific needs, ensuring that it remains relevant as new technologies and applications emerge. This flexibility is particularly beneficial for researchers who work across multiple disciplines, as it allows the use of a single system for a variety of tasks. The high speed of the X4 POSEIDON is another major advantage, especially for screening studies and quality control environments where rapid data acquisition and processing are crucial. In addition to its high speed, the system offers high resolution, which is essential for scientific research purposes. Users can capture the smallest details, making it possible to conduct more thorough and accurate analysis. The large field of view further enhances the system's versatility, allowing users to analyze larger samples or multiple areas in a single scan. This combination of high speed, high resolution, and large field of view makes the X4 POSEIDON an invaluable tool for a wide range of scientific studies. The ease of use of the all-new 3D X Suite software is another key aspect of the user experience. The intuitive interface simplifies the operation of the system, making it accessible to both novice and experienced users. Project management features help users stay organized and collaborate seamlessly with their colleagues. The fully integrated workflow from planning to reconstruction ensures that every step can be managed within a single platform, streamlining operations and improving efficiency. To accommodate users with varying levels of expertise, the system includes a protocol library for novices and full control options for advanced users. This flexibility allows you to grow with the system, enhancing your skills and capabilities over time. Overall, the user experience of the X4 POSEIDON is characterized by its adaptability, high performance, and ease of use, making it an indispensable tool for researchers in a wide range of scientific fields.
All right, so we are joined now by a few more of our team members. So welcome Jolien and Joris.
Hi.
Hey.
Good night or good evening.
So we have a few questions that actually came in during the video. Again, if anybody has questions, go ahead, put them into the side here. And the first one is, can I watch this later? And yes, we will be sending out a recording later. So if it's really late where you are, you can go ahead, go back to bed, except for these people, they have to stay.
And it is late there.
That it is. So what about the maximum sample size of this new system? Jolien, what's the biggest samples that we can be sticking in here?
Well, you can take a lot of different types of samples in there. And luckily, we have done so as well. So we do have a little bit of a measurement that we know. So we can fit about 110 millimeters in this case. Sorry, no inches from my side. In diameter and about 300 millimeters in height. So that's quite a decent sample size, I think, that we can fit in there.
All right. And another question that come in, with the X4 coming out, we have a bunch of other platforms already out there in our portfolio. We have the 1272, we have the 1273 and the 1275. What's going to be going on with those systems? I don't know who wants to answer that.
I think I will take that, John, if you don't mind. So, indeed, the POSEIDON is with this wide configurability is intended to replace two of the systems that we currently produce. So, over the course of the next year, we will be replacing the 1272 and the 1275 with the POSEIDON. The 73 strikes a perfect balance between higher power, higher penetrating power, and larger sample capacity, and is our most popular system at the moment. So we will keep that system in the portfolio as it is complementary to the X4 POSEIDON.
All right, and yeah, we're just going to have two Jorises here. We're going to have double the R&D. Oh, now he's back to one. Okay, so here's a good question for you, Joris. What's the range of kilovolts and the smallest pixel size? What's the X-ray source type? Is it open, closed, sealed?
Hello? Can you hear me?
Yes.
Yep.
Well, the range of kilovolts, that's an easy one. So it's really dependent depending on the source. You choose to work between 40 and 100 kilovolt, or between 40 and 110 kilovolt. The smallest pixel size, depends both on the configuration and the detector that you look at. I don't recall all numbers perfectly, but for the high-end configuration, we are talking about 200 nanometers, and smallest pixel size that we can effectively achieve. That's without, of course, you have a limited field of view, but you can have standard scans doing that pixel size. Configuration, for about 1 pixel size. It depends on the configuration. So you have lots of options depending on what your need is. Very small samples or bigger samples, higher dense or lower dense. So it's your choice.
All right, great. So now, kind of a follow-up to that previous question, Yulene, that you were answering, and that is, in terms of those sample sizes, what's the dependence on sample density?
Well, let's give it a try. That's usually the case, right? You
Yeah,
send the
that's right.
sample, we'll put it in the system, we'll see how much of a transmission we get through the sample. It really depends. The nice thing about this, one of the sources, is that it can go up to 110 kV, so we can kind of get into the range of a slightly denser sample. So yeah, just let us give it a try. That's most what I can say, I think.
All right.
Well, I would add to that, John, if I may. When we launch the system, we will have 16 application notes available for download, and they will give you a very complete picture of what you can do on variety of samples and sample sizes. So please check them out. You'll get a good impression of it.
Yep. And with that note, there is one question here about different materials, limitations, maybe electronics, and I would probably echo what you just said. Well, go ahead, head down to the expo area, and you can see all those application notes, or visit our website later, and you'll be able to see those application notes themselves. So with that, if anybody has additional questions, you can ask them there or send them in to us later. But we're going to kind of wrap things up here so we can move on to the live session. And just kind of wrap everything up, what we're going to do is just get some thoughts. So let's go ahead and let's start with Yolene.
All right, no worries. Um, well, the thing is that I am super excited about the system. So I've been scanning lots and lots of different things on it already, and I just hope I can continue doing that. I also hope that once we get more different applications, I get to see more of the variety that the system can do. And of course, I'm also super excited that once there are few systems out there, that we can actually train people on the system and see what they're going to be doing with it as well. So yeah, that's it from my side.
All right, great. And Joris, how about from that R&D perspective? Any last thoughts for everybody?
Well, R&D made a big effort to get to this point, and we are extremely excited to see the first results of our labs worldwide coming in with big enthusiasm. So that's really nice to see. But I think our story doesn't end here. We are aiming for the future, and that will go into this platform. So that will be very nice to see constant change on the product, but also on the software. So I'm really excited to keep working in that area.
All right, great. And then Kiel?
Yes. Very happy with this new system, which is completely configurable, and comparing to the current portfolio, which is fixed. I mean, sometimes you could go for application where your preferred system was one system, and but another application would then more fit onto another system. And budget is of course not unlimited, and sometimes you are really in the middle between two systems and had a hard choice choosing which one to go with. This is really over now, and of course there will always be compromises, but a lot less here, because you can configure it. You can go with a dual detector system if you like. So very excited about that and looking forward to work with all of you.
All right. And then right before we turn it over to Diederik for the final thoughts, I just want to remind everybody on the left side of your screen, once we're concluded here, you can head to the session area and we'll give you a live product demonstration of the X4 actually in action. You can also go into the expo. You can explore some of our different literature and information or reach out to us for additional information on the system. And with that, I will turn it over here to Diederik.
So yes, I'm extremely proud of the complete team and achieving this remarkable new instrument. And I would like to end by zooming out a bit, speaking in Micro-CT terms. This is the start of a platform series from Bruker, as you can recognize from the nomenclature of the name of the X4 POSEIDON. And we are very keen on keeping on delivering new innovation with our new Micro-CT platforms, and we would welcome you in our labs globally. So the system is ready on all the continents almost of the world and ready to receive your samples. So reach out to us. We welcome you to our lab, and we are looking forward to the exciting research that we can support you with. So with that, we will go to the live demo.
That's right. All right. Goodbye, everybody.
My name is Stefan Leroux. I'm the product manager for X-ray Microscopy for the material science side. And to my right, we have our application specialist, Billy Rees, who's going to be helping us today looking at this marvelous instrument behind us. So I hope you had a great first session looking at some of the more technical details, and now we want to dive a bit more into the details behind us about how the system works. So what some of you might not know is that Billy used to be one of our customers before he joined us a couple of months ago. So to get it all started, I want to ask you, Billy, so from your perspective, what are some of the great new features you are excited for about this new product?
So first and foremost, I really loved, I've been using CT for 12 years now, 13 years now.
Sure,
and
quite a while.
And one of the things I've been most impressed with on this system in particular, this flat panel is amazing. Like the flat panel is insanely fast. It's beautiful. I love it. It's amazing. It's been a pleasure to work with that. The new software design is a big improvement. I love this new software. The flow is really good. I've really been enjoying that. And then working with the team on the development side of things and watching the progression has been really awesome. It's been really fun.
That's amazing. Yeah. So before we continue looking at the system, I just want to give you a couple of pointers. On your screen, you'll see a bar on the right-hand side where you can ask some questions. So while we're busy and you see anything that interests you, please ask us some questions. And we'll see, and as we go along, I'll keep an eye on the questions tab and we'll answer your questions as we go along. So, Billy, you mentioned there's a couple of cool things. Software, you want to start there? Let's have a look and see what that looks like.
Yes, sir. Let's do it.
Yeah, perfect.
Okay, so as you can see, we're looking at a whole new software. If you're a user of one of our other systems, then you'll notice that this looks nothing like what you're used to. And then let's go ahead. We will do applications.
Just walk us through a bit more what's happening there. Like you're logging in. Are there user profiles? What are these profiles telling us? What are we looking at?
So the good thing is now we have, so the user is listed here, so applications, that's me, and then my role as an engineer. So one of the good things about this new software is you can set different roles. There's different levels of users that you can have. So you can have an advanced user, an expert level user who has access to the entire instrument and can modify things and make changes, all the way down to a more base level user who may only have access to certain things and maybe just start simple scans and something along those lines. So that variable user level is a really nice new feature of this. It also helps with data management.
So when you log in, for example, does everybody see all the data on the scanner, or do we have different? Is it separated from one another? Can you, like, for example, if a professor is doing some research and there are other students coming in, do they separate that from one another?
So with each user, one user will have access to their data, and then the other user will only have access to their own data. So each user had their data separated. So that's a really nice feature. And then the manager level or the top level will be able to access. They'll be able to see the entire data set. So data management was something it's been really nice to see the data management aspect of this software come into play.
That's great. And with these different user labels, I suspect the idea would be to have more advanced users,
Yes.
as well as having, let's say, less experienced users who also feel comfortable with the software, depending on how much they've used the software in the past, for example.
Yep. And part of that, one of the good things about having if you have varying levels of users, there's benefits on the next tab that I'd love to show y'all.
Please do. Let's have a look.
So first, on this screen, as you can see, you can get a good sense of the system status and kind of what's going on with the system. And then over here, you'll choose your product. So this is going to be one of those things where each user is going to have to define their different levels. So we'll go into this project, live demo, study. I think y'all all recognize this one, Starfish here. So we'll open this study. Now within a study, you can set up multiple scans. So for this one Starfish, if you're doing multiple scans, you'll be able to set that up here.
So give a bit of an overview of what you're seeing on the left-hand side over there. It looks like a lot of things. There we go.
So really easily, as you saw, you're able to collapse everything down. In the flow that I was mentioning earlier, you can see there's a nice flow to this. Everything just kind of makes sense top to bottom. Get your stuff set up. And then for those base users, I'm in the advanced mode, so I can see everything. But for the base users, let's say you just want them to be able to come in and set up a scan, and with set parameters, you can have scan protocols, predetermined protocols. They can come in, apply the protocol, it'll start your scan with those predefined settings. So that's a really nice feature.
So basically what you've done is you put everything that any user would need to set up a scan right there, front and center, so I can just follow these easy steps and they will be able to set up a scan with no problems, right?
Absolutely. No hidden menus. Everything's right here in front of you, and perfectly easy to pop these open. And also another nice feature, if you did want to pop one out and move it around, you can. Close it and it docks right back into the list here.
Just a moment there, Billy. There's a couple of questions I see you would like to address first. Let's see. First of all, I believe it is Windows 10 and allow remote control and diagnostics. Yes, so you can remotely access the system depending on what system you're running, and it runs on Windows 10, Windows 11, to Windows-based operating systems. So yes, you can remotely access it. Right. Second question. Is the new 3D Suite exclusive for the X4 Poseidon? Can older systems be installed with the new 3D Suite? The new 3D Suite is called 3D X Suite, and it is exclusive to the X4 Poseidon at the moment. That is correct, yeah. And I'm sure future developments will utilize this amazing new piece of software. And then lastly, let's see, can this new platform of software be applied to anything? And I think this answers the previous question. At the moment, that's not possible. The X4 Poseidon, this is one of our great new iterations or advances we're looking at. So Billy, another thing we've spoken about, and these are some of the advantages of this new platform, is the fact that you have a much larger field of view in some of the scans. We talk about speed and things as well, but let's have a look and see what this field of view shows us. And can you give us a bit of maybe a bit of a demo as we put a sample in what this looks like?
Yes, sir. Absolutely. Let's do it.
Great.
So let's go ahead and turn this on. So up here at the top, you can see your basic controls of the system itself. I'm going to click grab. It'll turn the X-ray on. And so there you go. I hope this looks familiar for y'all. So here's our Starfish in this massive field of view we have here. So I currently have the detector. You can see down here, I'm looking, let me start at the top here for everyone.
Yeah, just take a step by step.
Yeah, we will start. So up here, you can see the source power. So we can set our KV here and our current. We have our filters here. We have the automatic filter changer on the system. So if I wanted to, I could just very easily click another filter and it would change for me. We're currently on the flat panel, but we also have the flat panel and the CMOS in this system. We can set our exposure time here. And then down here, our scanner geometry. So one of the nice things is you can set your object radius so you don't crash into the detector. You're able to protect your very beautiful piece of equipment here. And then we have the pixel size here. So you can set, when you set this, it'll actually, this will move the sample closer or farther away from the detector, from the source. Your source detector distance will actually move the detector closer to the source. And then this allows you to move your sample up and down.
So, Billy, show us what it looks like when you zoom in. Let's see how much of a resolution or magnification improvement we can see when you start moving things around.
Okay. So we can get this into the full field of view.
Look at that. Amazing.
Yeah. So, and one of the benefits now with the system, also really easy to move the the sample around in the field of view.
If you have such an amazing micro-positioning stage installed, you can much easily position the sample in the correct position. As you can see, with the click of a button, you can literally just drag and drop the object around. You can move it to any position you need. Perfect.
And one thing I wanted to show, we talked about the speed. So one thing I want to show, so we're at 16 microns resolution here for the scan.
So before we talk about speed, like how do we achieve this speed? Like I heard things mentioned about base scan geometry. And can you explain a bit about how this works and how you would utilize base scan geometry in one of these scanners?
Absolutely. So with this system, so now we have our starfish in the full field of view. And so the current geometry that I'm in is I'm at 16 micron resolution and I have my source and detector distance set at 406. So the detector is all the way back.
So base scan geometry means you can freely move this camera to any position, correct?
Correct. And if you're familiar with other systems, there was a far, middle, and close. Now I have the freedom to move this wherever I would like. So let's get this back to, let's see what we can do for the fastest scan geometry. And also watch the screen and notice how it starts getting saturated. So let's get this back to 16 microns, like I was saying. So that's that full field of view for this sample. So now we're at a different scan geometry. But if we're going for fast time and with a different scan geometry, we're oversaturating our detector, right?
Before you move the camera, you were at 250 milliseconds per projection, correct?
Correct.
So now with it in its close position,
60.
Goes to 60. 4 times improvement.
4 times improvement.
Amazing. I can imagine with these improved scan speeds, Billy, you are definitely scanning more than you used to. Not sitting around waiting for scans anymore, are you?
Yeah, I will say it has been a struggle for me to keep up with the data, as well as the system to keep up with the amount of data I'm trying to collect. It's been a lot of fun pushing the limits and seeing what all I'm able to do, and seeing what all I can collect so much data so quickly. It's been a lot of fun.
So no more coffee breaks, like waiting for the scan to finish.
I got all the data I can process.
That's amazing.
And one thing, just really quickly, I did want to show you. So this scan, so in the fastest configuration possible, scroll all the way down to execute scan. Now this says 1 minute. We would have to double check all those settings here, but this is let's see. Let's do a 360-degree scan. We'll even do a little bit of frame averaging there. We'll do one frame averaging. 4 minutes. We're looking at a 4 minute scan for a full 360-degree scan.
Ah, perfect. What else do you need? What more do you need? Amazing. So, and I get the impression that we have so much more flexibility in this system, Billy, that, for example, you could have this large field of view. You can now freely move the detector to any position with the base scan geometry. Like there's no limitations anymore, really.
Yeah.
And now, with having multiple cameras, like how will this help us to strike the best balance between all of these different components?
Yeah. So what you saw in the video, we have 2 detectors in there now. So we have the flat panel, which is phenomenal, and then we also have the CMOS in there as well.
Yeah.
So one thing you'll notice if we go back to the software.
So I heard things called Gem Plus. Is that what we're talking about here, Billy?
Correct. We're correct. Yeah. So we're going to look at Gem Plus now. So the good thing is I'm going to collapse all these down so we can see things a little better. So Gem Plus. So let's get this a little closer. And then one thing I want people to notice is it looks like there's a lot of detail in here that we can see. So I'm going to go to 5 microns resolution. I'm sorry. Yeah. So let's go, I'm sorry, we're going to go a little closer than that. Go back to 250 milliseconds. And then you can start to see a nice level of detail in here, correct?
Correct. So, okay. So what I noticed there, which is very interesting, is that you can literally switch between cameras with the click of a button. Is that correct? You don't need to open the door and start moving things around. You just click a button and you can switch between the cameras.
Correct. We have the detectors integrated into the system, so there's no taking a detector out and putting a new one in. We have them both right there in the system for you. So if you get to that point where it looks like there's something more that you want to see, one click of a button and you're done.
Amazing. So let's have a look and see how this can be optimized to extract all that detail.
So now, if you look now, you can see we're going to be at 0.7 microns. We're at a higher exposure time, so it's going to take a little longer. And then you can see the detail that we've now unlocked here. So it's just another layer with the software that you can see. There's so much. We're at 0.69 microns resolution with this scan, and it's amazing. It's amazing the level of detail that we're able to see and the amount of information we're able to collect here.
Okay, thanks, Billy. So I want to glance over here at the questions again. I see one of the questions we have is, at the smallest binning size, how many pixels wide is the detector? So if you are asking about if there's no binning, for example, it means that you're not applying anything. The horizontal pixels are 4,096 pixels. And now if we go up to the next question, hi, how about bright dark field acquisitions? Wouldn't they have to be done at particular source state detector positions? That's going to be used for actual scans. Pre-programmed in a different geometries wouldn't work properly. Well, one of the things Billy can show you is that we've built in an option to automatically update the exposure time and the flat fields at these different positions when you would like to do a scan. You can quickly show in the software, Billy, if you can, where you can see this in the flat field updates.
Yep. So down here, and you can see up here on the top left in the software that it says if your flat field is on or off. Currently, the red says that I do need to update my flat field, but down here, when you do need to update your flat field, these are the options that you have. So you can have your system auto-adjust your exposure time, move your sample out of view. Some of these things will be very familiar to some of our other users. And then, yeah, click update flat field reference, and the system will do it for you. And then one of the good things is, before this live demo, I did these flat field corrections before we got set up. So I would be able to do some of these images live with y'all.
Oh, amazing. That's great. So I just want to touch on one more thing you spoke about earlier about these faster scans, for example, and high throughput, for example. And what you'll notice behind me is that we have our sample changer connected to the machine. And this is great because I've noticed, Billy, you have the low profile lid installed. And my question would be, what are the options? Why would you do that? And can you give a bit of an overview of what's going on there?
Yeah, so one of the nice things about this new system, we have the sample changer is now attached to the bottom of the system as opposed to being mounted on top. So if you're using the sample changer, you can have all your samples in here and it'll have its own lid. But if you don't need the sample changer, you can take the sample changer lid off. You can use this low profile lid. You still have access inside of the system. So you don't necessarily need to remove the sample changer.
That's amazing. So you can, for example, open the door, give us a look and see what that looks like.
Absolutely. Yep.
Yeah. So as you can see, for example, let's say you want to do your sample changer is connected and you would like to do an additional 4D experiment, for example, compression, tensile, temperature analysis. You still have complete access to the system, which is amazing, which also allows you, for example, to load up larger samples if you would want to, or a wide range of different applications without without it causing any interference for you in the system. Right. Okay. So I think we're going to wrap up the session. I think we've done a great job, Billy. Thank you very much for helping me. I'd just like to end off the session to say thank you for everybody who came to the session today to see. I just want to see, just spotting maybe some sneaky little last-minute questions I want to get to. Please go to the website. There are up to 16 method notes or application notes of different applications, both material and life science, where you can see what the great capabilities of our new product is, as well as an array of information about the product as well, where you can contact some of our sales team if you're interested, or for example, if you want to demo some of your samples. We're looking forward to talk to you in the future and hope to see you soon. Thank you very much, everybody.
Thank you.
Bye-bye.